today we're looking at sum and difference identities for sine and cosine. So let's first look at a problem really quickly. Does cosine of 30 degrees plus 60 degrees equal cosine of 30 degrees plus cosine of 60 degrees? So for this first part, if we add 30 and 60, this gives us cosine of 90 degrees. And 90 degrees we know is on our unit circle. It's this point right here, 0, 1. And cosine is x over r. So cosine of 90 degrees, here's my x, here's my y. Cosine of 90 degrees is 0 over 1 because our r is always 1. So cosine of 90 degrees is 0. Cosine of 30 and cosine of 60, if we use our chart, so cosine of 30 degrees is root 3 over 2. And cosine of 60 degrees is 1/2. And if you add these together, we're still not going to get 0. So it's clear to see that we cannot just add the cosine of these two different angles to get our answer for cosine of this. So that's why we have these sum and difference formulas. So whenever we're adding two angles inside the parentheses for either sine or cosine, we have a special formula to use. So there's 4 of these that we're going to need to know, depending on whether it's sine or cosine and if it's subtracting or adding. So if we look at problem number 2, this is clearly the expanded form of it. So right now we're going to see which of these 4 we're going to use. So if this is my A and this is my B, let me just rewrite this using A and B. So we have cosine of A, cosine of B, plus sine of A, sine of B. And I want to see which of the 4 formulas should I be using for this problem. So first I notice that there is an addition sign, so I know it's either going to be number 1 or number 4, because those are the two with addition. And I want it to be cosine, cosine, plus sine, sine. So looking at these two, the problem is going to use rule number 4. So rule number 4 tells me that this is equal to cosine of A minus B. And so since I know this is A and this is my B, I can rewrite this as cosine 3x minus my B, which is 2x. And to simplify this, 3x minus 2x is just cosine of x. And I cannot find cosine of x because I don't know what x is. And so this is just my final answer. Okay, let's look at number 3. So again, here's my A and here's my B. So let me first rewrite this using A and B. So this is sine of A, cosine of B, minus cosine of A, sine of B. Again, I'm going to try to see which of these 4 I will use for this problem. It's a subtraction sign. So with subtraction, I'm going to be using either number 2 or number 3. And I have a sine, cosine, minus cosine, sine. And that one matches rule number 2. And so I can simplify this to be sine of A minus B. Now I'm just going to replace my A and my B with the numbers given to you in the problem. So A is 105 degrees, B is 15 degrees. And so I'm going to subtract 105 minus 15, which gives us 90. So this is just sine of 90 degrees. Now sine of 90 degrees we can actually find, 90 degrees is right up here. So this is again one of our quadrantal angles. Sine is y over r. And in this case my y is 1. My r is also 1. And so sine of 90 degrees is equal to 1. And that's my final answer. Okay, let's do one more of this type of problem. So number 4. Again, here's my A, here's my B. Cosine of A, cosine of B, minus sine of A, sine of B. So it's subtraction, which means I know I'm going to be using either 2 or 3. And I want cosine, cosine minus sine, sine, which means I will be using rule number 3, which means that this can be rewritten as cosine A plus B. Now we're going to plug in my A and my B, so I have pi over 4 plus pi over 12. Now to add these together, these are two fractions. So in order to add them together, I'm going to need them to have the same denominator. So what I'm going to do is multiply this first fraction by 3 over 3 so that it can have a denominator of 12. So this is 3 pi over 12 plus pi over 12. Now that they have the same denominator, I can add them together. So 3 pi plus 1 pi gives you 4 pi. And then finally we can simplify this. Let's divide them both by 4. We end up with pi over 3. So pi over 4 plus pi over 12 give us pi over 3. So we're just finding cosine of pi over 3. And this is, again, something we can actually find looking at our chart. Here's cosine of pi over 3, which is 60 degrees, will give us 1/2. And so cosine of pi over 3 is 1/2, and that's our final answer. Okay. For problem number 5, now we're starting off with the left side of the identity. So we have cosine of pi plus x. So we're starting off with one of these right here, and we're going to be expanding it to this. So right now we're verifying, which means we're trying to prove that this is equal to this. So again, this is already my answer. This is what I'm trying to make it equal to. Okay, so cosine of pi plus x. Here's my a, here's my b. For cosine of a plus b, I'm going to be using rule number 3. So cosine of a plus b, I'm going to expand out to this right here. So I have cosine a, cosine b, minus sine a, sine b. So I'm just copying down the right side of this equation. And now I'm going to plug in my a and my b, so I have cosine of pi, cosine of x, minus sine pi, sine of x. And I can actually find cosine of pi and sine of pi, because pi, which is the same as 180 degrees, is over here. Here's my point for my unit circle. So cosine of pi, cosine is x over r. So because my x here is -1, I know my cosine is going to give me -1. Sine of pi, sine is y over r. Y in this case is 0. So 0 divided by 1 gives me 0. And I'm just going to plug these two in. So if cosine of pi is -1, this is -1 times cosine of x minus sine of pi, which is 0, times sine of x. So we can't simplify these two because we don't know what x is. Okay, so 0 times anything gives us 0. So this whole thing just cancels out to give us 0. -1 times cosine just gives me negative cosine. And that is indeed what we wanted to end up with, because we want to verify that this right here simplifies the negative cosine. So this is correct, and we are done with this problem. Okay. Last problem. So again, we're simplifying this expression. We're starting off with sine of a plus b. So this is actually two separate expressions in one. This one, see how it's a plus b, it's inside of our parentheses? Again, this is right now starting off the left side of our equation. So we're looking for sine of a plus b. So we're going to be using the first equation for this one. And for the second part of this expression, so over here we have sine of pi over 6 minus x. This is sine of a minus b. And so we're actually going to use the second expression, or the second equation for this one. So we're going to be doing this twice in this problem. So for this first one, this is sine of pi over 6 plus sine of plus x. So we're using this first one. We're going to write it out using this formula right here. So sine a cosine b plus cosine a sine b. we have sine of A, which is pi over 6, cosine B, which is x, plus cosine of A, which is pi over 6, sine B, which is x. So this is this first one right here. And now I want to add the second part right here, which is sine of pi over 6 minus x. So here's another a and b. This time we're using equation number 2 to simplify this one. So now we have sine of A, sine of pi over 6, cosine of B, which is x. And this one is a minus cosine of A, which is pi over 6, sine of B, which is x. So these two are the two separate expressions here, expanded out. Okay, so sine of pi over 6 and cosine of pi over 6 we can find out using our chart. And so if we look at what is sine of pi over 6, here in my chart, here's pi over 6, sine of pi over 6 is 1/2. And so I can replace my sine of pi over 6 with 1/2 cosine x. Cosine of pi over 6, here's cosine, and pi over 6 is root 3 over 2. Oh shoot, I put b here. This should be x, sine x. And then plus, again, sine of pi over 6 we found out was 1/2. Minus cosine of pi over 6 we found out was root 3 over 2. And now we're going to try to simplify this. So this is a positive root 3 over 2 sine x and a negative root 3 over 2 sine x. So these two actually are going to cancel out when we add them together because it's just going to give you 0. Now we're left with 1/2 cosine x plus 1/2 cosine x. 1/2 plus 1/2 gives you a whole. So this actually just leaves us with cosine of x.